Okay, so this is homework number 1, problem number 19 for the pencast. So here, I'm going to read the question out. I wrote some of the variables we need to know just ahead of time to make it easier. You can pause the video if you want and write everything down. Okay, so I'm going to read it out. A hammer taps on the end of a 4-meter long metal bar at room temperature. So 4 meters long, so that's delta x. They tell us right away. That's distance, basically. A microphone at the other end of the bar picks up 2 pulses of sound, one that travels through metal and one that travels through air. The pulses are separated by time 9 meters per second. What is the speed of sound in metal? Okay, so this is something we need to unpackage a bit. So basically, the pulses are separated by a time of 9 milliseconds. So we can know by that table where the index of or how fast sound travels through certain mediums, that when it'll travel through a solid faster. So that means we know that the time for metal is less than the time for air. So all we have to know is really the time for air and subtract it by this, and we'll have the time for metal, and then we can figure it all out, but let's take it step by step. So the first thing, we have an equation here for basically distance equals rate times time, but reformatted so that it's easier for the equation, or for the problem. So the distance is 4 meters. The rate of air is a constant that we all know, 343 meters per second. The delta t is an unknown. So if we just solve for that, we can go 4 divided by 343 meters per second meters equals delta t. And delta t turns out to be 0.01166 seconds, which we can convert to milliseconds, which equals 11.66 milliseconds. Okay, so remember what I said earlier with this whole unpackaging thing? So we know the air, and we know that metal is less than air. So if the pulses are separated by a time of 9 milliseconds, we can just go 11.66 milliseconds minus 9 milliseconds is equal to the amount of time it takes to travel for the metal. And if you do that, it's pretty simple math. It's 2.66 milliseconds to travel equals t of the metal. And now we can just plug it back into the other equation, which is also distance equals rate times time. So once again, distance, which is 4 meters, equals the rate, which we don't know. That's what we're trying to find out. What is the speed of sound in metal, which is v metal. We don't know that. And time, this is a t, by the way. So we know time. We just found out. So that's 2.66 milliseconds. Oops, not meters per second, milliseconds, my bad. So if we do all this, velocity of metal, let's rearrange this a bit, equals the distance, which is 4 meters, divided by the time, which is 2.66 milliseconds. And we can convert that to seconds by dividing the answer by 100? 1,000. 1,000. Fuck, hold on. Here. Everybody makes mistakes. Delta x equals delta t. So 4 meters equals 0.00266 seconds. We'll just do it like that. Equals 1,504 meters per second is the speed of sound in metal. Okay, that's it.